In the sun-soaked backyards of Florida, an invisible danger hides in plain sight. These ants create flat, circular patches of bare soil, bordered by small pebbles, which can stretch up to 35 feet wide. This is the Florida harvester ant, a stout creature armed with one of the most painful stings in the Southeast. But to find its most formidable relative, we must travel to the arid, wind-swept deserts of Arizona. Here lives the Maricopa Harvester Ant. To protect their homes from desert winds, they construct cemented nest caps out of calcium carbonate drawn from deep underground. But the Maricopa Harvester Ant is famous for another reason. It holds a Guinness World Record. It produces the most toxic insect venom in the world. With an incredibly potent LD50 value of 0.12 milligrams per kilogram, just 12 stings can kill a 2-kilogram rat. To put that into perspective, this ant's venom is more than 20 times stronger than the venom of a honeybee. Even the light vibration of a footstep on the ground sends a warning signal deep into the soil. The colony registers the disturbance instantly, shifting into a hyper-defensive mode to protect their nest. The first ants to emerge release a chemical alarm pheromone into the air, signaling others to attack. In seconds, the ants swarm out of the nest, reacting aggressively to any movement. When a harvester ant attacks, it first uses its large, powerful mandibles to lock a tight grip onto the victim's skin. Using its jaws as an anchor, the ant begins to pivot in a circle. This leverage allows the ant to repeatedly drive its stinger into the flesh, injecting venom over and over again. The venom is driven deep beneath the surface, immediately targeting the surrounding nerve tissue. Even if you swat the ant away, severed stingers can sometimes remain embedded, continuing to pulse venom into the skin. The pain of the sting is immediate and excruciating. Victims famously describe the agony as feeling like ripping tendons or turning a screw in the flesh. The injection site quickly erupts into a blister, accompanied by severe swelling and purplish discoloration. It triggers intense localized reactions, including goosebumps and extreme sweating directly around the wound. The venom is neurologically active, causing deep, nerve-like aches that can travel all the way up a victim's leg or arm. But the worst part is the clock. Unlike a bee sting, harvester ant pain actually intensifies over the following hours. This delayed escalation occurs because the complex venom slowly diffuses and disperses through the surrounding cellular tissue. For some victims, the throbbing pain can linger for up to 48 hours. In rare cases, a single sting can trigger anaphylaxis. Symptoms like facial swelling or difficulty breathing require an immediate call to 911. To understand why this venom is so devastating, scientists have broken it down in the laboratory. They discovered that the venom is relatively simple, composed almost entirely of peptide toxins. The primary culprits for the pain are two specific peptides, named PM1A and PM2A. When researchers injected just these isolated peptides into mice, they triggered the exact long-lasting pain and swelling seen in humans. These peptides are precision-engineered biological weapons that specifically target mammalian sensory neurons. They bind directly to voltage-gated sodium channels, which are responsible for generating pain signals along the nerve. By lowering the threshold required for the nerve to fire, the peptides act like a broken switch, preventing the nerve from turning off. This creates a massive, continuous influx of pain signals flooding directly into the mammalian brain. Astonishingly, when these exact pain peptides are injected into most insects, they have almost no effect. This reveals that the harvester ant's agonizing venom evolved specifically to deter vertebrates. But why would a tiny desert ant need such extreme chemical firepower against large animals? The answer lies deep underground, where these colonies act as massive granaries. A single harvester ant nest can hoard up to 500,000 collected seeds, making it a highly attractive food source. Mammalian granivores, like kangaroo rats, are easily tempted by these massive subterranean food caches. The ant's incredibly potent sting acts as the ultimate deterrent to keep these thieving mammals away. However, their greatest nemesis is not a rat, but the Texas horned lizard. This specialized predator relies almost entirely on harvester ants, with diets consisting of up to 98% ants. To survive the venom, the horned lizard evolved a special factor in its blood that detoxifies the ant's sting. This incredible predator-prey relationship represents an intense evolutionary arms race spanning millions of years. Sadly, the chemical weapons built for lizards and rats are now frequently unleashed on human lawns. If you are stung, the very first step is to leave the area immediately, as the alarm pheromones will attract a swarm. Gently wash the sting site with soap and water to clear away bacteria and prevent secondary infections. Apply an ice pack for 10 to 15 minutes to numb the nerve pain and reduce the intense swelling. Over-the-counter oral antihistamines and topical lidocaine gels can help manage the intense discomfort. Frustrated homeowners often try to destroy the colonies themselves, pouring boiling water or borax over the mounds. But this fails completely because the tunnels can plunge over 20 feet underground, keeping the queen perfectly safe. Under attack, the surviving ants will simply relocate a few feet away and pop up with a new mound days later. True eradication requires pest control professionals who use precision injections and insect growth regulators to eliminate the colony. Yet in their natural habitat, harvester ants are vital, enriching the soil by dragging dead insects underground to decompose. The harvester ant is a master chemist and an ecological titan, a creature demanding our distance and our ultimate respect.